Another poor MacBook Air that is dead. Does not turn on. Just sad. So if we plug in the charger, we get no fan spin. So I have the I/O board unplugged just to see if that's preventing power up, and we still get no fan spins. So let's take apart this MacBook and see what is wrong with it. So the first things first is we're going to unplug all the cables, like the I/O board cable, the LCD connector, the Wi-Fi antennas, keyboard backlight, and that's about it. So we're going to start to take out the very few screws that the 11-inch Air has. 11-inch Airs are kind of fun to disassemble because there's really nothing to them. There's just a few screws, that's it. One thing to note though is the Wi-Fi card does have to come out to take the one screw under it out, but that's no big deal, of course. And another trick on these is I like to take the battery out sometimes when I put the board back together, because the DCN cable is kind of funny to get it slide under the battery. Now, one thing to note, and I made this mistake before, and I'm going to show you guys so you guys don't make the same mistake, is the webcam connector. So what I learned on this, and this was, if you just pull it, and I know the urge to just pull it, I mean, I've had this urge, I just pull them sometimes. Don't do this with this connector, because if you can see, it's not like shrink tube like a lot of the other ones are, and if you pull this, what's going to happen is it's going to rip all the wires out of the webcam connector, so don't do that. Instead, get your tweezers and slide it out like that. Okay, our board is out of the enclosure with nothing connected to it. We're going to go ahead and plug in our charger. So the charger is now plugged in, and we can see it's dead. So let's give the board a visual inspection as always. This one looks pretty clean. I don't think this has any liquid damage, but we'll see if I'm wrong. So here's our CPU vCore area. Everything looks good here. Don't see anything wrong here. JTAG connector looks nice and clean. 11-inch Airs, it's pretty common for the JTAG connector to corrode. And on this one, it looks just beautiful. Q7130 looks good. 3V42 circuit looks good. Backlight circuit looks good, except for this. So wait a second here. So we do have a little bit of corrosion there. That doesn't look too bad. And this isn't even turning on, so what do we care about backlight? So LCD area looks good. Everything looks pretty decent on this side. I don't see anything of concern. But if we go on this side, let's see if there's anything different. So ISL looks pretty good. Our TPS 51916 looks good. Looks like it just has hairs on it. That's it. Have some slight, now if you see this on a board, so see how these probe points have a little bit of green on them? Where is it? So you see that? This is actually going to be from the humidity in the air and not a liquid spill. So humidity in the air can do that. So if you have the MacBook in the shower with you or whatever from steam, then yeah, that can cause them to corrode. See how this right here, same thing. That resistor is a little bit corroded. So this could be humidity damage. And wait a second, what is this? So look at this. Here's probably our issue right here. So this is our SPI ROM area. And we can see this probe point is clearly corroded. You can see this area is corroded. There's just quite a bit of corrosion right here around the BIOS. So this is probably our issue right here. So SPI ROM is very important. So this is the BIOS, and if we do not have BIOS communication to the CPU or anything like that, then this board is not going to work. So the first thing I'm going to do is give this a general cleaning and go from there. So this cap looks like it's shorted. You can see how it's like kind of a different color than it should have been. I think that's going to be C6100. So I'm going to start with a general cleaning of this area, and then we're going to go from there and replace what we need to. We might be able to get away with just touching up some stuff, maybe replacing that capacitor. But I'm just going to put some flux down, and we're going to gently heat this and see if it works or what happens. So I'm going to turn on my hot air station and my soldering iron, kick on the fume extractor as always, and go 430 degrees at 30% airflow. Just going to clean this up with flux. flux is a really good cleaner for corrosion. It just eats away everything. With the combination of heat, it just eats away at whatever is creating a bridge. We get rid of this capacitor because this could be our issue. That capacitor is just a smoothing cap. It's nothing too important. So we don't need that for now. And I'm going to go on max air. I want the chip to actually be reflown. And it is. So while that's cooling, I'm going to go ahead and look around at other areas of the board, like our SMC. So we have some corrosion right here. We might have junk under the SMC. Have some corrosion there. That's not really near anything important though. This is Thunderbolt. All this should be fine after ultrasonic. Let's inspect our U1950 area. Where is it on this board? It's somewhere here. Yeah, the common areas don't look too bad. Everything looks good there. So yeah, most likely it was just that cap and the junk around here. So now with that junk removed, I'm going to go ahead and turn it on and see if it works. Now if it does not work, we may have a broken trace, but I think it'll work and we could get away with some touch-ups and replacing that cap. So we're going to plug it in and we can see the fan is now spinning. So wait, or is it? Is it going to do its power cycle thing? What's it going to do? So this is a 3435, so it should spin up, shut off, spin up, shut off when it's doing an RTC reset when it first turns on, and it actually does not look like it's completing that cycle. It looks like it is just spinning up and shutting off. So that's probably going to be a fun one. So we're going to plug in the OEM charger now instead of the power supply charger. And we get nothing. So this becomes a lot more fun now. So we most likely have a blown SPI trace right here. So what we're going to do is clean this all up with a Q-tip and alcohol and see if we could find where our trace is broken in this area. Because we definitely know we have an issue now. And most likely it's going to be in this area, but the question is which trace is the issue. I don't think that capacitor would do it though. Unless it was shorted, but we kind of ruled that out by removing it. Now these traces actually don't look too bad. Usually it's the probe point that breaks. We're going to keep cleaning here. And then what I'm going to do is scrape away at each of them and to see if I have a break on some of them. So usually it'll be a really it actually won't be too distinctive. You'll see a little tiny break, like maybe right here. I don't think so though, because these actually don't look too bad at all. Yeah, these don't look too bad at all. Seen way worse. Now this one on the other hand looks a little off because if you look, no, that's okay. There's still copper, so we're good there. A little bit there, nothing too bad though. So let me touch up some of these that I scraped, because we know it's probably not right here, and I'm also going to grab a capacitor for that in a second. Now, note, we also had that near the SMC. There could be junk under the SMC as well, but we're not going to go reflowing the SMC just yet. We always want to use our brain a little bit. We don't want to turn into a complete please bro and start reflowing everything. I know, even though that's easy and it's nice when that works, but not here, not today. So I'm going to go ahead and touch these probe points up, get a fresh layer of solder on them, and if there is a break, sometimes that'll fix it. Whenever you get a probe point that's not taking solder, it's usually because it was pretty badly oxidized. See there, that's good. Yeah, sometimes if there's a little break, what you can do is scrape away at the probe point and reconnect it with the copper trace with solder, if you're lucky. And a lot of times that works just fine. Now this one might be broken. I can't tell if that's corroded or broken. Where this via is, it's kind of hard to see with the glare, but it looks like it's not taking solder too well either. But it looks like there is a connection there, so it's probably not that. So I have to scrape a little bit more at it. We'll probably have to use our brains on this board. It's always nice to not have to use your brain on a board. Just scrape away the oxidation there for that capacitor. We're going to put a new one on. That resistor is a little bit corroded too, so a little fresh solder wouldn't hurt that. I'm also going to touch up the pins in the BIOS itself. Sometimes if you have a corroded one, the BIOS very rarely fails from liquid damage. It's a pretty tough chip. So yeah, most of the time it is not the BIOS. It's either a connection under the BIOS or an issue around the BIOS. So now that I touch that up, I want to see if we get fan spin again, because placing heat could mean a broken trace. So if it works after we put heat on it, oftentimes there'll be a broken trace that... Okay, so our fan is spinning. It did the quarter fan spin thing. Now let's see if it does it again, or if it just stays dead. Give it a second. And it looks like it's staying dead. So when this happens, it could either be, like I said, a broken trace. If we put pressure on the board. Okay, so what I'm going to do now, I have the DC power supply plugged in, and with this plugged in, I'm going to put a little bit of heat in this area to see if I can see which trace is broken. So this is okay to do. You're not going to kill anything doing this. I'm going to put a little bit of heat here, and I'm watching current draw on the DC power supply. Nothing there. And what this is going to tell me is if it works with the trace hot, I probably have a break in that line. Nothing yet. Nothing yet. Nothing yet. So I'm just going to go around here and put a little bit of heat on each trace and see if I get a fan spin. It does not look like I am. And heat isn't really going to hurt a resistor either, so. Okay, so now it's time to use my brain. So a few things could be happening. So we could have a short on an SO rail. We could have a short on an S3 rail. We could still have an issue around there or around the SMC, especially if that's corroded, but that doesn't look too bad, because that's going to nothing. So at this point, I'm going to start checking my power rails. So the first rail we need, of course, is PP bus G3 hot. We're going to see what PP bus G3 hot is. It should be present because we are getting fan spin, so I'm going to grab my multimeter. I'm going to put this on voltage mode and go back to the camera view so you guys can see. Let's go back to camera view. Here we go. So here's the multimeter. Let's move the alcohol so you guys can see that. So hopefully that's visible and clear. I am going to check PP bus G3 hot, and that is going to show up. Where's the fuse on this board? This is a 11 inch. Where's the fuse? I know it's somewhere here. Alright, backlight fuse. That's no good. Wait, is that? Here's why. So that should be 8.5 volts. Okay, now that is cycling a little bit. So what this cycling is telling me is the board is actually trying to turn on. It's essentially quarter fan spinning, but something is stopping it from turning on. So when that cycles, what's going on is it's putting a load on it. So as soon as it puts a load on it, it's going to drop the voltage a little bit. So now we have to kind of try and find what's doing that. Now that sounds very much like an SPI issue, but there's some other things that can cause that. So next thing I'm going to measure is going to be PP5VS5. So let me pull up the schematic and board view. So let's open up the board view. And this is an 820-3435, which is an 11-inch MacBook Air. This board was used from 2013 to 2014. And then replaced by the 820-00164. The only real differences between the 820-3437 and the 820-00164 is going to be the CPU. I believe the 00164 also has quad SPI instead of dual SPI. But this one uses a Haswell CPU, and the 00164 uses a Broadwell CPU. And the differences on those is the process nodes. So the Haswell has 22 nanometer, and Broadwell is 14 nanometer. So Haswell tends to be more reliable from what I've seen. Broadwell tends to be more lousy. So PP5V_S5 is going to show up around U7400 on C7400. So U7400 is going to be almost directly under the BIOS. So right here, let's plug it in again since I unplugged it. Let's plug it in. But our issue almost seems to be related to heat, but it could also be from heating up this cap right here. So I need to go back to my window so I can see the meter, because I have to see it on this screen to see it. I'm going to measure PP5VS5 right here. And that is 5 volts. It's not cycling or anything, so we're good there. Now we're going to measure PP3V3S5. So PP3V3_S5. And did I hit record on this? Because that would be really terrible if I didn't, but yes I did. So 3V3S5 is going to show up under U3560, and U3560 is going to be off this side of the BIOS, and that is a, let me find that. So okay, it has these two resistors under it right here. And that is 0 volts, I think. So PP3V3S3 is 0 volts. So the board is not going to turn on without PP3V3S3. Let's make sure I'm making contact there. Yep. So the board is not going to turn on at all without PP3V3S3. And I know our board is working because we have 5 volts here. And I know we have power to the board, but we have nothing on PP3V3S3. So we're going to, PP3V3S5. So we're going to check for a short now. So we're going to put our meter in diode mode right here. Make sure I measure the right thing. Yes, I did. And we're going to check for a short on this. So we have no short, but it's not coming online. Let's check again with the OEM charger just to double check things before replacing stuff. I always like to use my brain a little bit before replacing stuff. Voltage mode. It's always good to double check things. It's always good to triple check things. Okay, where is it? Right here. That is 0 volts. So PP3V3S5 is going to come from, let's have a look here. So PP3V3S5, we're going to open the schematic here. I'm going to pull it up on display capture. So let's find this schematic for this board. So 3435, open the PDF. Let's go back to OBS. We are going to turn on display capture. Okay, so PP3V3_S5. Let's see where this comes from. So let's try and find this on the schematic and see if we can figure out where that is generated from. So we see this as this powers our clock chip. So if this isn't powering our clock chip, the board is not going to work. We don't care about that though because it's not even present. We want to make sure this is present. So we have to figure out what generates this. Could see a lot of stuff is really dependent on this to work. But what's this right here? So what do we see here? We have U7501. Now U7501 is the buck controller regulator for Q7560. So Q7560 is going to take PP bus, S5, H other, iSend. So what this is going to be is it's basically going to be PP bus G3 hot. So we could see that this is going to be the supply voltage for this chip. And we could see that this chip is going to switch that 12 volts into a nice regulated 3-volt output. So how this is going to work is it's going to take that 12 volts through this transistor right here, and it's going to switch it 12 to 1, 12 to 1, 12 to 1. And when it goes through this inductor, it's going to come out a nice 3.3 volts, nice and steady and stable. But we're not getting that. So we have a couple possible issues here. So for one, we could be missing the VIN to this. So PP bus could be missing, but we already checked that, so we know that's present. Now it's also possible that PP bus is not making it to this. And another possibility is that there's a blown trace somewhere in this area that's causing this not to send its output to Q7560. It's also possible there's a broken trace between Q7560 and L7560. So we're going to have a look at this part of the board. So this is going to be the U7501 area. So we're going to do a search on the board view here for U7501. We can see that's going to show up near our SMC. So here's our SMC and here's U7501. So let's switch back over to microscope view and we're going to have a look here. So here is U7501 and we can see this actually looks perfectly fine. We don't really have an issue here, or do we? So before I go forward, what do you see here? So just looking at this with your eye, what do you see right here? So what do you see off with this chip? So if you look closely, we can see that we have some liquid that got under this. So right here, see that? What's that? That's junk right there. So we have some junk right there. And most likely with junk being under that chip, it killed this poor chip. And this chip is now dead. MacBook does not want to have a dead chip on it. If the MacBook has a dead chip on it, it's probably not going to be happy and it's probably not going to work. Okay, so let's see what we have to do to make this thing work again. While we're at it, I might as well flux this area too and clean it up. I'll remove the edge bonding off the SMC and give that a nice little reflow. Not hot enough to melt solder, but just enough to clean that up. So let's get our hot air on, max airflow. Yeah, see that right there? You can kind of see the contamination around that chip. So that got a little bit of liquid by it. I'm gonna take the edge bonding off before we cook it. So I want to take the edge bonding off first, because if we cook the edge bonding, it's gonna be a pain to take off later. So should not be too hard to take off at all right now. The flux kind of gets under there too and helps take it off. What do you know? This one's actually not being a pain. It's actually coming off. But take note, please don't take every piece of edge bonding off your board like some people do, because that is not good. Do not take every piece of edge bonding off of your board. It's especially not nice to take every piece of the edge bonding off the board and then send it to me to fix. Because if you do that, I'm probably not going to fix it. It's not a nice thing. It is complete disrespect. It is a disgusting practice of complete disrespect to remove every piece of edge bonding off your motherboard and then send it to someone to fix. Get out of here, get out of here. Come on, get out of here. The edge bonding becomes invisible with the flux on it. It's another little piece right here. This should not be hard to get off. There we go. So now we can go ahead and take U7501 off. So U7501 is right here. And U7501 is off. I'm going to clean this up. We're going to clean all that nasty lead-free solder and replace it with good solder that may or may not contain lead and may be known by the state of California to cause cancer, birth defects, and other reproductive harm. So by doing this, I'm going to move all that lead-free solder into my iron. It's also going to create an alloy, which is going to allow the solder to be picked up by the wick a little bit better than it would if it was just plain lead-free. So oftentimes if you try and wick lead-free, it's going to turn into a huge mess. Now that's two reasons. One is lead-free is just hard to work with. And secondly, Amtech 559 does not wet lead-free solder very good. So it's going to be harder to wick. You can use a flux like Amtech VS213, which will allow you to solder lead-free solders beautifully, but the issue with that is it's harder to clean. Well, it's not harder to clean, it's a very good flux to be used in small amounts, but anytime you start to use large amounts, need to ultrasonic it, the ultrasonic won't touch it. So I only recommend Amtech VS213 for small touch-ups. So we have a nice solder on those pins now. We have a bridge right here. Bridges are no big deal. Little flux. And there we go. It's nice and clean. We're going to put a little bit of solder on the thermal pad. Just like that. And we're just about ready for our new chip. We're going to clean up some of this old flux. We don't really need to clean it with alcohol. We just kind of want to remove it. And it's also fine to leave fibers down. It's not going to do anything. I just kind of want to get rid of some of that old stuff so I can put some fresh flux down, which will help solder the chip better. The burn flux does not work as well, and you will It depends. Sometimes if you push it down, if the flux is really burnt, you'll get a bridge under it, but that's kind of rare. So I'm going to align this semi-good. Doesn't really need to be aligned because it'll pull itself into place. And once I see it start to get soldered like that, I can go ahead and release it, let it pull itself into place, just like that. See how it's in place now? Now that it's in place, the solder's dry, I can go ahead and push it down. Like that. That is a nice soldered U7501. I'm going to clean up these pins. Just like that, nice and clean. Yeah, that's a nice looking U7501. Now the real moment of truth is, will this turn on normally? Will the fan spin? Will it spin, then stop, and then not start again? Will it spin, stop, spin, stop, spin, stop, then start? Let's see. So we plug it in. We're pulling 0.2 milliamps, but no fan spin. That's no fun. Okay, so now let's see if PP3V3 S5 is back. So let's check and see if that's back. So, too bad. I was hoping for a fun one, but this board does not look like it's going to be a fun one. It looks like it's going to be a troll board. Okay, now PP3V3 S5 is still not present. So, let's have a look around the chip again. Make sure it's soldered right, and it is. And that doesn't make much sense because usually we're fine after we change that chip. So, I see a little bit of junk right here, but that's not going to cause anything. So let's see what pins on the chip. So let's, for one, go back to the schematic and let's see what pins are going to cause that. So P3V3S5 VBST, P3V3S5 DRVH, that's driver, so that's going to be the gate driver. P3V3S5LL, no idea. P3V3S5 DRVL, no idea, and a bunch of other stuff. So a few things can cause this. So if we look at our schematic, if the chip died and shorted, so that's a possibility. If the chip died and shorted, it may not be shorted now, but it may have shorted, burned up, and then the short burned itself out. So if we look at our schematic, let's go back to display capture. We have a 0 ohm resistor right here on P3V3 V biased. So this is going to go into our transistor. Now, R7564 may be blown if the chip shorted at any point in time. So let's check that. So R7564. So R7564 is where? So R7564 is going to be right under the chip. So that's going to be right here, and that looks pretty good. I don't see any issues with that, but let's go ahead and measure that real quick. So we're going to go to ohms mode and see what that's measuring. So in ohms mode, this resistor is measuring 0 ohms. That's not our issue. Let's go ahead and check for a short around here. Aha, right here. Oh wait, nope, that's good. That's really strange, honestly. I almost wonder if we got a dead chip. Yeah, that's really strange because that's pretty much, everything's pretty much here. And this is a pretty simple circuit. It's also a possibility that C7588 is missing off the board. So C7588, where's that at? So C7588 is right here at the top, and that is present and well. Okay, so I plugged in the OEM charger just for the heck of it. So OEM charger is plugged in, and the fan spins. And let's see if it'll power up normally with the OEM charger plugged in. And it spins again. And it spins again. Let's see if it stops and actually powers up. And it does. Yeah, this should be fixed. This was actually a case of me getting trolled by a charger. So sometimes what can happen is if you have a bad charger, what's going to happen is it's going to let PM bat low L stay low. So normally if the charger is good, it's going to let that signal go high to let the board power on. Now this signal, if the battery is low, as it says, it's not going to let it power up. So if the battery is super low, like way below design voltage, the SMC is going to talk to the PCH and say, nope, you're too low, I'm not going to let you turn on. So PM bat low is going to go low, and PM bat low is required for PM sleep S4L assertion. So if that's going to be missing, then we're not going to get power. And a lot of times, if it's a knockoff charger that's kind of acting funny, the board won't like it. So this is the knockoff charger connected to my power supply, and now it works, which is even strange. So maybe the board was just too hot. Maybe the board was just too hot when I tried to turn it on. That could have happened as well. So as far as I know, this is fixed. I'm going to go ahead and put it back in the enclosure real quick. Maybe there's junk under that SMC too, so I'm probably going to give this SMC a little reflow. So I'm going to give this SMC a flux reflow real quick. Since there was junk around here, there's probably junk under that, and we didn't really get it good last time. So I'm going to take this opportunity and give it a good little reflow. Now remember, I'm only doing this because I suspect corrosion under it. I'm not doing it just because. I see more and more people starting to say that or do that is just reflowing SMCs out of nowhere. And no, don't do it unless you suspect liquid under it. Use your brain a little bit. And that's good. The next thing that I need to do is replace that little capacitor. So that I think is going to be C6100. If I remember correctly, that's C6100, which is probably going to be stolen off of every donor board I have. And yeah, that is C6100, but not to fear, we have more donor boards on the way. So let's grab a new C6100. That's going to be a 0.1 microfarad, I think. So the board would work fine without C6100. That's only there to smooth out the 3 volt line going into the chip to power it. Just helps take out a little bit of that noise that's going to be present on that rail. Now, leaving that cap off is not a big deal, but if that cap shorts, it's going to pull down 3v3 sus, and it will not work that way. Go into place. There, now this is good. This can go in the ultrasonic cleaner in a minute here. Actually, I need to turn on the ultrasonic because I came back to work at 9 o'clock at night, and of course the ultrasonic will not be on when I come to work at that time. So we're good to go here. I'm going to put it in the enclosure real quick to test because I know there's going to be that one person that, that one person in the minority that's going to say, well, you can't test that with just fan spin. There's more wrong with the board and you just don't want to show us. So I better make that person happy by testing it in the enclosure. Let's clean up all this nasty flux. You know what? This needs to be cleaned anyway because this is full of crumbs and trash that just fell out of it. And now I'm probably going to get ants because someone ate over their laptop. Don't eat over your laptop, please. It's not a good habit. Eating over your laptop is actually a disgusting practice of complete disrespect. So let's plug this in. Of course, my luck this one time, it's not going to post or something stupid like that. Watch. Now that I said that, this thing isn't going to post. So you know what? Screw having it lined up. It doesn't need to be lined up. I'm trying not to touch the edge of the board because it's full of flux and I already got it on my hand. And I don't like getting flux on my hand. It's gross. So it's plugged in. Let's get our charger. Plug it in again. Pen spin. It's going to do its spin stop thing, so it's going to take a few minutes or a few seconds to go through that. And it's turning on normally now. Fan spin, fan stop, fan spin, fan stop. Why these boards do that, I don't really know. I think it has something to do with RTC reset, but I've, so look, see that? Fixed. I'm not a liar. I actually fix things. It's not posting. If we get this, it means it posted. So this board is fixed. So we had a bad U7401 or U7501. Also had some corrosion in the SPI termination area. We took care of that. And with that being said, this is going to go in the ultrasonic and be sent back.